What we see here is the effect of vibration on a specific substance, lycopodium powder, or spores of the club moss. We have strewn it uniformly on a diaphragm of stretched paper with a diameter of about 30 centimeters, which we now excite by vibration. This causes the powder to clump. We can see many small clumps, many small globular piles, and the more intense the vibration, the more piles there are. If the note is louder, that is to say, if the amplitude is increased, these masses of powder move to the center and make a kind of dust cloud there. An ever wider area of powder is affected, and more of these globules are formed. They are not at rest, but in a state of continuous motion. We can see a large circular shape forming in the middle and continuously moving. Sometimes it is whipped up into a cloud, as it is now, and sometimes it reverts to the solid dust particle form. These changes are caused by the differences in the intensity of the tone, that is, by the different amplitudes. In this experiment, the frequency, that is to say, the number of vibrations per second, is the same. And now we see the circular form and everything in a definite pattern of movement. Now we shall take a closer look at these movements. Here is one of these forms. We can see how the material rises up in the middle and is transported to the periphery. This pile of dust, this heap of particles, is in a process of convection. The material travels inwards from the edge along the bottom of the pile, rises up in the middle, and is then carried back to the periphery. Even if the intensity of the vibration changes, there is still a whole system of radial circulation. At certain frequencies, or with certain tones, an extraordinarily interesting phenomenon is seen. Watch. We see two regularly and continuously rotating areas at either end of a diameter, going round and round like weathercocks. This is the expression of a rotating wave motion. We can see they are rotating in an anti-clockwise direction. We now switch to a different frequency and produce the same phenomenon, but this time in a clockwise direction, because the frequency is different. If we go back to the previous frequency, we have the same phenomenon again in an anti-clockwise direction. Notice that this rotary movement does not affect the circulation or convection in the least. Now we can excite the same material with different tones all the way through the frequency band and watch what happens. Here we have lycopodium powder at a relatively soft-sounding tone, and we see that the pattern figures most prominently. We have motion too, and circulation, but above all, it is the structural pattern that strikes the eye. And all the shapes lying about here, looking like monkey nuts, have these patterns of structure. Again and again there are convection cells, circulatory systems, forming there, making structural patterns in the lycopodium. Now, by changing the amplitude, that is, changing the volume of the tone, we can bring about a very interesting phenomenon. The tone is the same, but we introduce a burst, an amplitude burst, and every time we do so, it integrates the whole situation. These dynamic events now lead to a phenomenon of exceptional interest. You must realize that the same diaphragm and the same powder are used, but that the tones are different. Here we have a flow pattern. This means that where we had a structural pattern before, we now have a violent dynamic one. A current is formed and the powder rushes along in the flow path, leaving the black patches of the diaphragm completely free of powder. Everything is driven into the flow path by the vibration. We add more and more material, but the result is not confusion or chaos. Instead, everything falls into place in the strict flow pattern. A point to notice about all these phenomena is that they can be reproduced at any time, that the factors and conditions of the experiment are known with accuracy. We go on throwing in powder, and every time this attractive and clearly defined flow pattern keeps on emerging from the vibrational field. It is a circulatory system without walls. The walls are, so to speak, the area of vibration. The area of vibration provides the constraint which gives shape to the circulatory flow. Different flow patterns are formed at different frequencies. This is a kind of double current. but at other frequencies we have, as it were, a four-part or quadrantal pattern. Here we have a formation with four fields. Here again we throw in powder, and once more it is embodied in the exact quadrantal flow pattern created by the vibration. This is a particularly interesting phenomenon because it reveals not only the structuralizing effect of vibration, but also its dynamic and kinetic effect. Here we have a cloud of lycopodium powder created by vibration, and in it we can see extraordinary life and movement. We have eddy formations and sometimes even regular pairs of vortices. Then we have turbulences or unstable wave formations. And the interesting thing is that during all this welter of movement we have a structuralizing element on the diaphragm. At the very same time there is this zebra pattern on the diaphragm. Its one pole is structure and its other pole dynamics. Even if we intensify the vibrations and make a very thick cloud, this pattern still takes shape on the diaphragm. As we slowly reduce the tone, which is a decrescendo to the ear, the pattern created comes into view. In the vibrational fields of this lycopodium and of other materials, we saw time and again that in certain places the material is thrown up, then all is quiet, then it is thrown up once more, then all is quiet again. We saw that it kept to certain places, that it did not splash about just anyhow, but that everything took place in particular spots. In this shot we can see how there is one place on the diaphragm in the middle of our picture where the material keeps on being thrown up. And observation has shown that what we have here is an interference phenomenon. The action of the waves is cumulative, their effects are summated at these spots, causing the mass to be ejected. Then quiet returns. Then there is another summation. These events are reminiscent of processes in solar physics in which a tendency to repetitive eruptions, solar eruptions, has been observed. This repetitive tendency is particularly prominent in the chromosphere. Here, interferences are at work. Here we can watch what these hemispheres are doing. There are many different things to see. Structure, for instance, which we have observed before, and which appears on these circular forms as patches. Convection, which we have also observed before, can be seen here too. But what is particularly interesting about these hemispheres is the curious way they move. They creep round. They do not disintegrate, they do not break up or crumble. And as they creep round, they take everything with them. When movement takes place in one direction, what happens is that all the material slips and glides along together. These small circular forms move like amoebae, but only like amoebae. They are not living systems. They move like amoebae, or, to borrow a term from biology, they move correlatively. These are movements of correlation. That is to say, the movement always takes place as a whole. Also, we see how these small formations unite, combine, and separate. In this way, we realize there is always a whole. We always have something entire and complete before us. This is a particularly interesting phenomenon. We are able to discover it by using crystal oscillators. There are rotary processes, circular movements, which proceed with absolute regularity. Centrifugal force is not a factor here. The whole pattern is elicited by continuous parallel waves. Here we can see the currents running in contrary directions and creating a rotary effect or revolution. Here there is something very interesting to watch. Once again we have interference. That is to say, there are two tones. One moment the waves summate, then they cancel each other out. They summate again, and every time they summate, we have dynamics. And when they cancel each other out, we have rest and structural pattern. We see structure alternating continually with dynamics. Structure and dynamics. What we see then is not caused by switching the vibration on and off, but is itself a vibrational phenomenon. Structures appear, clouds are formed, there is movement and change, forms emerge, all as the result of interference. Whole squads of forms appear, unite again, separate again, but always there is wholeness. It is as if these vibrational fields were providing models for a holistic theory. Here again we have continuous waves. These are very large diaphragms, rubber diaphragms, more than a square meter in size. Whole squads stream along in one direction, others in another direction. Structural patterns appear, structural patterns unite. We are looking into a whole landscape of lycopodium created by vibration. Once again, we have material rotating under the influence of continuous waves. And we can see how, in certain places, there is an inward flowing current, and in other places, there is also an inward flowing current from the other direction. So we have, as it were, rivers of material flowing in from diametrically opposite directions, and they are then revealed in these regions of rotation. The points of inflow are diametrically opposed in these rotating areas. Here we can see very clearly how the material flows in at bottom left and top right at diametrically opposite points, and in this way is incorporated into the rotary process. Here again there are currents, parallel continuous waves moving in opposite directions, which carry powder along with them. This last experiment is really extraordinarily interesting. We are looking into a funnel. We apply vibration, and the material is brought out of the bottom of the funnel. It is transported upwards against the force of gravity. But it is not simply thrown out. It moves round the periphery of the diaphragm, round its circumference, and then goes down into the funnel again. If we intensify the tone, then the upward march of the material is preponderant. If we make the tone soft, the material slides down again because the static friction on the undersurface of the diaphragm is reduced. The adhesion is reduced, and consequently the powder slides down again when the vibration is less intense. Sometimes then we have a process in which the material moves out, and sometimes a process in which it slips back. When it slips back, it covers the whole cone. When it slips out, it climbs up the wall of the cone. So, on the one hand, we have an anti-gravitation effect, and, on the other, a sliding effect resulting from reduced adhesion. When the vibration is of a particular character, we have a process in which the material is transported out and, at the same time, slips back, so that there is a convection current on a grand scale. This is a detail from part of the edge. It is a complex phenomenon, but all in all, its organization is unitary. Anti-gravitation, a downward slide due to reduced adhesion, and convection of the whole mass of powder. Here we see a heated and therefore liquid blob of kaolin excited by vibration. In this experiment we can follow how the phase of the material changes as it cools. First of all, we have wave fields. We can watch the liquid substance rippling. Gradually it cools, and the liquid phase changes to the plastic, and from the plastic phase it proceeds to the solid phase, and we can therefore speak of solidification under the influence of vibration. Here, the plastic state has been reached. There are no longer waves, but a clumped mass which is rotating and circulating in itself. The substance gets harder and harder and more solid until, when it has cooled, the kaolin is completely rigid. All these forms, all these structures which we see here, have been created purely and simply because the substance has solidified under the influence of vibration. We see branched and ramifying patterns. These are not crystallized forms, but sculptural shapes resulting from vibration. We can call them dendritic structures, finally passing over into filigree. What is involved then is a change of phase under the influence of vibration, solidification, that is, as an effect of vibration.